No, I hope you spent some time on this thinking about what's in between 7/11 and 7/12. So I want to show you the work of one student in this study. Her name was Annie, and Annie wrote this. First of all, notice, even though we said between 7/11 and 7/12, Annie wrote 7/12 and 7/11. As you saw in my video, that is the correct placement of the two videos. 7/12 is smaller than 7/11. So in terms of a number line, Annie was probably thinking 7/12 is smaller, 7/11 is bigger. So we're going to look in between. Now look at what she did. What's in between 7/12 and 7/11? How about 7/11 and a half, 7/11 and a quarter, 7/11 and a fifth? Let that soak in for a minute. Annie said if you took a whole and cut it up into 12 equal parts and took 7 of them, then took a whole and cut it up into 11 equal parts and took 7 of them, well, in between that would be taking a whole and cutting it up into 11 and a half, 11 and a quarter, 11 and a fifth. Now, I don't know why she picked a half, a quarter, a fifth. She could have picked anything, of course, but she picked 11 and a half, 11 and a quarter, 11 and a fifth. Now, you need to know that Annie is at the end of a 5th grade year where they've been working with fractions in some of the ways that we've been thinking about fractions. And so for her to think about this, to be in a classroom where thinking is expected, first of all, where trying things is expected, she was just thinking. And this is what they weren't taught to do this. Nobody said, hey, Annie, this is how you should do it. Annie was just thinking. And this is what Annie came up with. Now, this is the beautiful part about teaching in this way. Rather than trying to create robots where teachers say, here's how you do it, now mimic me, and you walk around the room coaching students to do it exactly the way you taught them. Instead, at least in this case, the idea was, hey, we've taught you a lot about thinking about what fractions are, what they mean, different ways of thinking about fractions. Now, try this problem. And then let's just see what happens. And around the room, there were lots of things, but Annie had this way that I want to share with you. Now, look at what she did. Now, remember, this is at the end of a 5th grade year with fractions. So there was other things that she knew. This was just a challenging exercise in the moment. And so 7/11 and a halves, 7/11 and a fourth, 7/11 and a fifth, because that's in between 11 and 12. Isn't that nice? But then watch this. 11 and a half. 11 wholes. 11 wholes is the same as 22 halves, right? 22 halves is a half and a half and a whole. A half and a half make a whole. A half and a half make a whole. So 11 would be 22 1/2s plus another 1/2. So 22 1/2s, 23 1/2s, 23 copies of a half. 44 fourths, 44 1/4 is 11. Why? Because it takes 4 fourths to make a whole, another 4 to make another whole, another 4 fourths to make another 4. 11 of them, we'd have 44 fourths. So this is 44 45 fourths. And then 55 56 fifths. So she has 7 23 halves, 7 45 fourths, and 7 56 fifths. Can you imagine this? A student who's in a classroom culture where thinking is expected and encouraged and cultivated. We have students who think like this. And then, because they've been working, this is not like first time Annie's ever seen a fraction. She's been working through a unit on fractions. They've added, subtracted, multiplied, and divided. So she even knew how to divide the fractions. And what she did here is she did 7 divided by 23 halves. And I'm just going to tell you the algorithm at this stage because we haven't gotten to that yet in our class. But when you take 7 divided by 23 halves, the algorithm is to say 7 times 2 23rds. 7 times 2 is 14, so 14 23rds. 7 divided by 45 fourths is 7 times 4 45ths. 7 times 4 is 28, 28 45ths. 7 divided by 56 fifths is 7 times 5 56. 7 times 5 is 35, 35 36ths. So Annie ultimately gets to these 3. 14 23rds, 28 45ths, 35 56ths are all in between. Check it out if you don't believe it. It's true. Now, we have some thinking, part of an interview here, and he says, you can get two fractions in between those two by making the bottom numbers. Preferred that she would have said denominator, but by making the bottom numbers in between 11 and 12. You can make any number of fractions you want between them. She just chose half, 11 and a half, 11 and a fourth, 11 and a fifth. Now, she did do some division as well. 7/12 is 0.583, 7/11 is 0.636. So then she says, let's pick 7/11 and a halves. And if you double the top and the bottom, look at how she did this. If you double 11 and a half, you get 23. And if you double 7, you get 14. 14/23. And that's 0.608. So it's in there, she says. She's checking her work here. Probably had a calculator. She took 14/23 and gets 0.608. And notice 0.608 is indeed in between 583, and 636. Isn't that great? And she did that for all of them. She probably then said, let's do 4 times this one. 4 times 11 and a fourth would be 45 and the 28 45ths, and then 5 times this one would be the 35 36. So she had all the thinking, and she was checking her work along the way. You have to trust me here that when thinking is expected, encouraged, and cultivated, students will think. And they don't have to just mimic what somebody tells them to do. And then in a classroom situation around the room where there's lots of different solutions, lots of different ways of thinking, we can share, we can talk, we can discuss, and it's a vibrant, really exciting learning environment. So that's Annie and her fraction challenge.